Hello everyone, today we're going to present the video about remote sensing. So let's start. The remote sensing is the acquisition of information about an object or phenomenon without making physical contact with the object and thus in contact to on-site observation. Remote sensing is used in numerous fields including geography, land surveying, and the most earth science disciplines such as hydrology, ecology, oceanography, glaciology, geology. It also has military, intelligence, commercial, economic, planning, and humanitarian applications.
Passive sensors gauge the radiation that is emitted or reflected by the object or surrounding areas. Reflected sunlight is the most common source of radiation measured by passive sensors. Examples of passive remote sensors include film photography, infrared, charge-coupled devices, and radiometers. Active collection, on the other hand, emits energy in order to scan objects and areas where often a sensor then detects and measures the radiation that is reflected or backscattered from the target.
The basis for multispectral collection and the analysis is that of examined arrays or objects that reflect or emit radiation that stand out from surrounding arrays. For a summary of major remote sensing satellite systems, see the overview table.
Conventional radar is mostly associated with aerial traffic control, early warnings. Laser and radar altimeters on satellites have provided a wide range of data. Ultrasound and radar tide gauges measure sea level, tides, and wave direction in coastal and offshore tide gauges. Light detection and ranging, LIDAR, is well known in examples of weapon ranging, laser-illuminated homing of projectiles. Stereographic pairs of aerial photographs have often been used to make topographic maps by imagery and terrain analysis in trafficability and highway departments for potential roads. Simultaneous multispectral platforms, such as Landsat, have been used since the 1970s. These thematic mappers take images in multiple wavelengths of electromagnetic radiation. Hyperspectral imaging produces an image where each pixel has full spectral information with imaging narrow spectral bands over a contiguous spectral range.
Geodetic remote sensing can be gravimetric or geometric. Overhead gravity data collection was first used in aerial submarine detection. This data revealed minute perturbations in the Earth's gravitational field that may be used to determine changes in the mass distribution of the Earth, which in turn may be used for geophysical studies as an GRACE, its satellite. Geometric remote sensing includes position and deformation imaging using in SAR, LIDAR, and etc.
Also, sonar. Passive sonar, listening for the sound made by another object, a vessel, a whale. Active sonar, emitting pulses of sounds and listening for echoes used for detecting, ranging, and measurements of underwater objects and terrain. Seismograms, taken at different locations, can locate and measure earthquakes after they occur by comparing the relative intensity and precise timings. Ultrasound, sensors that emit high-frequency pulses and listening for echoes, used for detecting water waves and water level, as in tide gauges for towing tanks.
Next is a spatial resolution. The size of a pixel that is recorded in a raster image, typically pixels, may correspond to square arrays ranging in side lengths from 1 to 1000 meters. Spectral resolution, the wavelengths of the different frequency bands recorded usually. This is related to the number of frequency bands recorded by the platform. Radiometric resolution, the number of different intensities of radiation the sensor is able to distinguish. Typically, these range from 8 to 14 bits, corresponding to 256 levels of the gray scale up and to 16,384 intensities or shades of color in each band. It also depends on the instrument noise. Next is the temporal resolution. It's the frequency of flyovers by the satellite or plane, and is only relevant in time series studies or those requiring an averaged or mosaic image as in deforesting monitoring. Radiometric correction allows to avoid radiometric errors and distortions. The illumination of object on the Earth's surface is uneven because of different properties of the relief. Atmospheric correction, elimination of atmospheric haze by rescaling each frequency band so that its minimum value is usually realized in water bodies, corresponding to a pixel value of 0.
Next, it is about the remote sensing applications which used in our life. Remote sensing data are processed and analyzed with computer software, known as remote sensing application. A large number of proprietary and open source applications exist to process remote sensing data. Remote sensing software packages include ERDAS Imaging from Hexagon Geospatial, PCI Geomatica, TNT MIPS from Microimages, E3C from Clark Labs, eCognition from Trimble, and Remote View made by Overwatch Textron Systems. Dragon IPS is one of the oldest remote sensing packages still available and is in some cases free. And also the open source remote sensing software includes Optics, also Orfeo toolbooks. Others mixing remote sensing and GIS capabilities are GrassGIS, ILWIS, QGIS, and TerraLock.
Next, there are some advantages of the remote sensing. The first is satellite images are permanent records providing useful information in various wavelengths. The second is large array coverage enables regional surveys or on a variety of themes and the identification of large features. The third is repetitive coverage allows monitoring or dynamic themes like water, agriculture, and etc.
Also, the fourth advantage is it is easy data acquisition at different scales and resolutions. Fifth is a single remotely sensed image can be analyzed and interpreted for different purposes and applications. Sixth is amenability of remotely sensed data for fast processing using a computer.
Next is a map revision at medium to small scales is economical and faster. Color composite can be produced from 3 individual band images which provide better details of the area than a single band image or aerial photograph. And the last one is floods over a large region or the forest fire can be located from above and the rescue planning can be immediately arranged.
Also, in these pictures, you can find the examples of remote sensing and how it looks in the maps and also the types of the images.
And thank you for your attention.
Thank you for watching this video and also subscribe our channel and like them. Okay.